Welcome to our project DeviationFinder, an elevator anomaly detection system. What motivated us in doing this project? Let's look at some of the reasons behind it. Elevators have become an integral part of any building structure due to its ease of transporting people in minimal time. Not only elevators help us to get to places a little faster, but they also make urban living possible across all high-rises in the world. Like every other machine, elevators also require periodic maintenance. Failure to do so can make your life less efficient. Safety of elevators are ensured by certified technicians through routine inspections. However, increasing development of new infrastructures result in many more installation of elevators, demanding more inspectors in this area. Acquiring new workforce and training them can be expensive and time-consuming. Hence, it is important to set up an automated process that can effectively find anomalies in elevators using Internet of Things and artificial intelligence. Motivated with this possibility, we decided to work with Technical Safety BC to analyze accelerometer data installed across different lifts to identify some of the key issues related to elevator brakes, elevator motor, and elevator alignment. Now comes the data collection phase. Thanks to Technical Safety BC, we obtained accelerometer data spanning across 15 different lifts for 2 months. The data structure includes triaxial accelerometer data along with the timestamp. Sampling frequency was at 25 Hz, which is 25 data points per second. Single axis in accelerometer shall help us in identifying vertical movement, whereas the other two signifies horizontal movement. Volume of data was 75 GB, which of course is big data. No project is an exception from challenges, and we too had a few of them, such as processing huge volume of data, dataset with no labels about anomalies. Each lift had its accelerometer placed on different locations of lift, resulting axis and direction changes, minimal set of features, finding patterns in huge datasets, and generalizing a model that can fit all types of lifts. Our initial focus was to study on the anomalies that can occur in vertical movements. Considering this, we delved into the process of data cleaning. First, we extracted accelerometer data for a specific time range that captured useful readings. Then, we uniformized all accelerometer data pointing in negative axis by flipping them to positive quadrant. We also had to find the right axis among X, Y, Z that captures vertical movement of data. Another important aspect was Z normalization to standardize samples to zero mean and unit standard deviation. This helped us in finding structural similarities and dissimilarities in data. We also performed a low-pass filter using moving averages to reduce noise while retaining the sharp responses. An example is highlighted here. Our first task was to figure out a way to understand normal and abnormal patterns for all 15 lifts. To do that, we did exploratory data analysis. We did judgmental sampling using basic statistical methods to locate base bands and peak bands in a cycle. Plotting those samples helped us to find patterns of abnormal cases as well as normal cases where a lift goes up and down. Our initial idea was to implement a standard anomaly detection without machine learning to capture normal peaks of acceleration and deceleration. Here is an example of an anomaly occurred at 1633. First, the distance for each point was calculated using mean and standard deviation. We created partitions of data worth 60 seconds in a single window. Within each partition, we checked whether the data points are 4 standard deviations away from the mean. Such points are classified as outliers. If we have more than 5 outliers within a single window, we classify them as anomaly. We still have a lot of work to do. We would need to create different unsupervised models, evaluate the performance of each model, build a streaming environment to do real-time detection of anomalies, and finally serve the model in cloud. A quick view of our GitLab repository.